So in this video, I'm going to talk through how to solve word problems with quadratic equations. The new stuff in this lesson is the skill of being able to read the word problem and translate that into a quadratic equation. Solving that quadratic equation we've already done. Well, it's the skills that we've already learned. So the new stuff today is all about that translation between the words. There's probably going to be a picture to help us and then an equation. So let's read this one. It says a garden measuring 12 meters by 16 meters is to have a pedestrian pathway that is W meters wide installed around it, increasing the area to 285 meters squared. How wide is the pathway? For all of these problems, I start with a diagram. And starting with a diagram will help you eliminate a lot of the common pitfalls that we find with these problems where you just interpreted something not quite right, so everything after that is wrong. A lot of that stuff is solved by the diagram. So here's the original garden. It's 12 meters by 16 meters, and we're installing a pedestrian pathway around it. So what are the new dimensions? Because we know that the new area, the area of this whole thing, is 285 meters. And we know that the way that we find area is length times width. So what's the area of the whole thing? Well, we have to ask, what's the new width of this thing? It used to be 12 meters, but now we've added W meters here and W meters there. So now the width is actually 12 plus 2W meters. And in the same way, the length, we started with 16, we added a W, we added another W, so it's 16 plus 2W meters. If you hadn't drawn the picture, it would have been really, really easy to make the mistake of doing 12 plus W instead of 12 plus 2W, because you have to remind yourself that the walkway is on both sides, so you kind of add that W twice to the dimensions. Now how do we find W? Well, we have all the information we need to set up a quadratic equation, and it's going to look like this. We do length, which is 12, or width, 12 plus 2W, times length, which is 16 plus 2W, and that's going to equal 285. Another really important thing to remember when you're doing these is that we are working in one variable. So oftentimes, you could express like length times width is 285, but we can't solve if we've got two variables. So you've got to figure out a way to manipulate things. You've just got one variable to worry about. And here that variable is W, which is the width of the pedestrian walkway. Now you just need to solve this thing. I will warn you, this is not the nicest one to solve ever. I'm going to go through it in this video. If you're not worried about the solving right now, feel free to stop watching and move on if you're just worried about the skill of going from word problem to equation to solve. But if you want that, here we go. So to solve a quadratic equation using factoring, we need to get the whole thing equal to 0. And to do that, we're actually going to have to distribute this thing out so we can subtract the 285 from both sides. So we need to do some foiling, and it involves some big numbers. 12 times 16, I don't know off the top of my head. It is 192, great. So 192 plus 24W plus 32W plus 4W squared equals 285. Now we can subtract 285 from both sides. Minus 285, minus 285. This is going to get us something negative, so I'm going to do 285 minus 192. And I know that my answer is going to be negative, so it's going to be a negative 93. And now I'm going to rewrite this in the order we usually see quadratic equations. So 4W squared plus 24 plus 32 is 56W minus 93. And that's going to get us 0, because that's why we did that, so we can make this thing equal to 0. Can we factor anything out of this whole polynomial? No, because the only things we can factor out of this are a 2 and a 4, and neither a 2 or a 4 will come out of a 93. So we need to do whatever method that you chose to solve to factor a quadratic equation when the a value is not 1. My personal favorite is the x method. Let's do it. So the x method, a times c goes up here, so whatever 93 times 4 is, which is 372. B goes down here, to negative 372. And now our job is to figure out what multiplies to negative 372 and adds to 56. This took me a minute. I used a calculator. I already did it. Our answers are 62 and negative 6. 62 times 6 is equal to 372. 62 minus 6 is equal to 56. Now I'm going to rewrite this using grouping. So 4 times 4w squared plus, 62x minus 6x plus, minus 93 equals 0. So all we did was rewrite the 56 as 62x minus 6x, but we know that that's going to help us because of this whole x method. Now we can factor by grouping. So what can I take out of these first two? Just a 2. Well, 2x. Oh my gosh, I messed up my w's and my x's. Let's make them all w's. A 2w will come out of here. And we'll have 2w plus 31 left over. Out of 6w minus 93, we actually can take a 3 out, a negative 3. So we're going to do negative 3, and then we're going to be left with 2w plus 31, which is great, because if these two things don't match, then something terrible happened. I'm going to actually bring us up here to finish this out. So this is going up here. Now we factor out that 2w plus 31, and we are left with 2w minus 3. That equals 0. So now we can use zero product property to figure out what our width actually is going to equal. If we use zero product property on this one, well, we're going to get w equals negative 31 over 2. I just subtracted the 31 divided by 2. Width cannot be negative, so that one's not going to be our answer. And for this one, we got positive 3 over 2, or positive 1.5. That's much more likely that our width is 1.5 meters. Okay, and that's our answer. The width of this thing is 1.5 meters. We could always check that by doing, just like doing the new length and width, seeing if we get 285. I know that was a lot. I know the numbers are like really annoying. It happens. You have all the skills to work through that stuff. What I want you to focus on today is just getting from the problem to the diagram and the original equation.